triangle KLM is right triangle. Right angle is at vertex K. Point G is the midpoint of hypotenuse LM. Show that G is the same distance from each vertex of triangle KLM. Because triangle KLM is right triangle and right angle is at vertex K, I put K in the origin because it will be very easy to find the distance when we have point which has coordinates 0, 0. So we have that K is the right, in the point K we have right angle, and next I put two legs of our right triangle, one on the x-axis and one on the y-axis, because it will be very easy to calculate the distance, because first coordinate for point L, let's put that will be A, but the second on the x-axis is 0. And for M point, first coordinate is 0 because we are on the y-axis, so we have 0, and the second, let's put that this is B. One more time, why I put this right triangle in the xy plane, and why one leg is on the x-axis, one on the y-axis, because it will be very easy to calculate the distance and the length, because one coordinates is 0. And in the origin we have both coordinates 0. Next we have given point G, and G is the midpoint of hypotenuse LM. So here will be our point G. And because G is the midpoint, it means that the point G divides the segment into two congruent segments. So this segment LG is congruent to MG. This is from the definition of midpoint. What else? Now, to find coordinates of G point, we will use midpoint formula. So first coordinate we have to add first coordinates of point M and L and divide by 2. So will be 0 plus A over 2, and the second coordinate we have to add second coordinates and divide by 0. So will be B plus 0 over 2. So we have coordinates of G point will be A over 2 and B over 2. This was given, and now we have to show that G is the same distance from each vertex. So from MG, LG and KG is the same distance. So let me write this. We have to show that MG is equal LG and is equal KG. So let's use distance formula to find distance between M and G. And because G is the midpoint of ML, so MG is equal to LG. So we can write that this is equal LG and is equal square root of, let me remind you the distance formula. This is our first coordinate x1, y1. This is second point x2, y2. The distance formula will be square root of x2 minus x1 to second power plus y2 minus y1 to second power. So we will have G is the last point, so we will have A over 2 minus 0 to second power plus B over 2 minus B to second power. So this is equal square root of A square over 4 plus B square over 4. So this is equal square root of A square plus B square over 4, because we have the same denominator, so we can add these two fractions. So square root of 4 is 2, so in denominator we will have 2, and in numerator will be square root of A square plus B square. Next, we will find the distance between K and G. This is equal square root of G is the last point, so you will have A square A over 2 minus 0 to second power plus B over 2 minus 0 to second power. So this is equal square root of A square over 4 plus B square over 4. So this is equal square root of A square plus B square over 4. So this is equal square root of A square plus B square over 2. So we got that Kg is equal to Mg, and we know that Mg is equal to Lg. If you don't believe me, you can always check. Lg is equal, we have to use the same formula. So Lg, G is the last point, so we have to subtract from the last. So it is A over 2 minus A to second power plus B over 2 minus 0 to second power. So this is equal square root of A over 2 minus A is negative A over 2 to second power, so will be A square over 4 plus B square over 4. So this is equal square root of A square plus B square over 4. So this is equal square root of A square plus B square over 2. We got the same value, the same expression. It means that Mg is equal Lg and is equal Kg. This is my solution.